Hi, my name is Jacob and I'm a consultant at the Math Lab. And the purpose of today's video is to show you 3 possible areas that you can use to get an STL file for an object that you want to print. So the first command that I want to show you in Mathematica is parametric plot 3D. The way it works is you provide a list of functions for x, y, and z, and you provide the bounds. However, if I run the cell as it currently is, we get a shape where the very walls are very thin. And in fact, they're technically infinitely thin because it's a series of points. This cannot be used to 3D print because it's a sheet of infinitely small thickness, which is a problem. To fix that, you have to include a plot theme thick surface. What that does is it provides thicker walls, so that way your shape actually has dimension to it. So if we run the cell again, we can notice now that we've got thicker walls, and then for this shape can be 3D printed. An important note is that even though I'm going to be showing you these commands, this is not a tutorial on how to use these commands. I am merely just showing you examples of commands that can be used in Mathematica to produce these 3D shapes. Another command that can be used is contour plot 3D. And based on this setup, you provide an expression, the bounds for x, y, and z, but you still have to include the plot theme's thick surface for the exact same reason as before. There's also region plot. Region plot 3D, you can provide an inequality. You can provide the bounds for x, y, and z, and it will create a 3D region because it's producing the region of it. You don't necessarily need the plot theme thick surface, but it is better to be safe than sorry. And if I run this cell to save it as part 3, then I can show you how we have to export it later. But first, there's a couple other commands we can use. There's revolution plot 3D, which can be shown as such, and then there is spherical plot 3D. Both of these need plot theme thick surface because they provide shapes originally with infinitely thin sheets. Now, once you've made your file, you need to export it. So to do so, you can use the export command. Now, I've already gone through and put in the file path, but if this is your first time, then what I recommend doing is you save the notebook where you're going to want to find your files. Once you have done that, it makes inserting the file path much easier. So what you have to do is you would put the cursor right where you want it to put the file path. You go to Insert, File Path, and then you would have to normally go searching for it, but in my case, since I've been coming in and out of this folder a little bit, it is showing up right where I need it to. So I'm going to select Object 1. So that'll provide the basis of your file path. However, what you will have to change is the very end of it. And that is just because you're obviously not going to want to have it named by the file that you just used to get the file path. So I'm going to call this part3.stl. Then I'm going to label the variable that I used. So I used part3 right there. So I'm going to change this to part3. And then you need to tell it what file type you want to use. Do you want to use JPEG, STL? In this case, it is STL, so we'd have to use STL, all caps, and quotes. And then we can run the cell. And it's only going to output the fact that your file path. That's all it's going to output. However, if we go and check it out in the File Explorer, we can see that it is part 3. It's an STL file. And if I were to open it, it would be exactly what part 3 was. Another way you can get STL files is through Thingiverse. Thingiverse is a website that is a free depository for people that have made things and they want to share them. So as you can see, based on the home page, there's a bunch of different things that have been put on here, be it from chaz to knobs to a screwdriver handle to a whole bunch of other things. And if we searched up MTU, you can find some files that are related to Michigan Tech. However, I cannot guarantee that they're going to have everything you need. However, they do have some things that are Michigan Tech related, such as this statue or even this logo. So if you click, whenever you find what you're looking for, you can click on it. And if they have multiple views, such as if they've actually printed it in real life and they're providing a real life photo, they can also include those. You might even get other views. This can be opened into a 3D space, that way you can rotate it around and take a look at it. And if it is what you want, then you can click download all files, where it's gonna download it as a zip file. And here I want to save it to where I want to find it. And then all we have to do is you have to unzip it, which can be done with 7-zip. You can then access the folder that it makes and go into files, and you will find the STL files in there. Sometimes they will note that they have a file in there that if you open it with specific software, you can customize it yourself, but don't expect that. That is not very common. But sometimes they provide files that way you can customize the thing that you have found. Another way you can get STL files is to make them yourself using CAD software. This video does not cover all of the different types of CAD software out there. I have just provided some, so that way you have a basis. There's Tinkercad, which is a browser-based CAD software that is maintained by Autodesk. You will need a personal account, or you can even use a school email to make an account with them to use it. However, there's also FreeCAD, which is free and open source, but it can take some getting used to. It is a little bit difficult to work with, but that's because it is open source and free. You can also use SolidWorks, which is also made by Autodesk. It's not free for personal use, but it is available on campus computers if you want to use it, if you feel comfortable doing so. Fusion 360 is also made by Autodesk. However, it's got a limited free personal license. But again, it operates a lot like NX, so if you're very familiar with that. There is OpenSCAD, which is free and code-based, which will take some challenges because it is code-based. And then there is NX, which you may be familiar with ENG 1101 and ENG 1102. In which case, you can either use it on the campus computers or you can download it from the Software Distribution Center. That is all for this video. In the next video, I will show you how to load, manipulate, and slice files in Cura.